Hello friends, today I will discuss on the topic classification of dryers and fluidized bed dryer. To begin with, let's recall the definition of drying and its application or purposes or why drying is necessary. So at first, definition of drying. Drying is defined as the removal of liquid from solid by thermal method. When large amount of liquid is evaporated from solution, suspension, slurry, the process is called as evaporation. Final product is a concentrated liquid or slurry. But when very small amount of liquid is evaporated from the solids, the process is called drying. The final product is a dried solid. That means when we will, after evaporation of liquid, when we will get the product as a dried solid, then the process is known as drying. And when we will get concentrated liquid as a product, then it is called as evaporation. This is the basic difference between drying and evaporation. Now, the purposes of drying in pharmaceutical industries, or why drying is necessary in pharmaceutical industries. So, drying is the most commonly used method in pharmaceutical industries in the preparation of granules, which can be packed in bulk or compressed into tablets or filled in the capsules. Next point is drying is required for processing of materials like drying of aluminum hydroxide, spray drying of lactose, and preparation of powdered extracts. Next, it is used to reduce the bulk weight that lowers the transportation and storage cost of materials. Drugs obtained from plants and animal sources when dried becomes more friable. Thus, drying helps in size reduction of natural drugs. Next point, animal and vegetable drugs are preserved against mold growth in dried condition. Dried products often are more stable than moist ones, as in the case of effervescent salts, aspirin, hygroscopic powders, ascorbic acid, and penicillin. Now, today's topic of discussion was classification of dryers based on the heat transfer mechanism. So, basing on heat transfer mechanism, it is classified into three categories: convection dryers, fluidized bed dryers, conduction dryers, and radiant heat dryers. Convection dryers examples are tray or self dryers, tunnel dryer, rotary dryers, and fluidized bed dryers. In case of conduction dryers, examples are vacuum oven and freeze dryers. And in case of radiant heat dryers, infrared dryers. So, in the coming slides, we will discuss about fluidized bed dryer. The heat transfer mechanism in this dryer convection is convection. So at first we will see the principle of fluidized bed dryer, on what principle it works. So let us consider a situation where a bed of granules is placed over a perforated bottom container and hot air is flown from the bottom through the bed. The pressure drop delta P, or that is log delta P, across the bed, and the air velocity v are measured. If the velocity is gradually increased, we will get a curve. When we plot a curve between log delta v versus log delta p, and the velocity is gradually increased, then we will obtain a curve like this. In this curve, we are seeing 5 points: A, B, C, D, and E. Point A, it indicates that when the air velocity is very low, flow takes place between the particles without causing any disturbance. At point B, when the velocity is increased to certain value, the frictional drag on the particles become equal to the force of gravity of the particles. But at point C, rearrangement of particles occurs to offer least resistance. At point D, eventually the particles are suspended in the air and can move freely. So delta P decreases slightly because of greater porosity. Further increase in the air velocity separate causes the particles to separate and move freely, and the bed is fully fluidized. Any additional increase in velocity separates the particle further, that is, the bed expands without appreciable change in delta P up to the point E. In the DE region, the air flows through the bed in the form of bubbles. So, the term boiling bed is generally used for this stage. Above point E, the solid particles entrain into the gaseous phase and the particle floats in the gas. Now, construction of a fluidized bed dryer. Fluidized bed dryer are of two types: vertical fluidized bed dryer, for batch process, and horizontal fluidized bed dryer for continuous process. There are different parts, 5 different parts of a fluidized bed dryer. First one is air handler. Air handler, this is a source of dry and hot air. It is also attached by means of heating and dehumidifying air if necessary. Heating means air heaters are attached to this apparatus. This air inlet, air heaters, air outlet, this all three consists of air handler. Next part is plenum. It consists of a screen or plate to distribute the incoming air as it enters the dryer. So this portion is called as plenum. Product container. The container holds the product that is to be dried. So this is product container. In this container is having perforated bottom through which this hot air can pass into the products. Now next part is expansion chamber. This chamber is situated just above the product container and holds the suspended material. Last part is filter bags or filter. The upper part of the expansion chamber has bag filters. It prevents fines from escaping into the atmosphere or collecting on the blades that pulls the air through the dryer. It is on the top, a fan is also fixed which removes the moist air from the dryer. Applications of fluidized bed dryer. Mainly there are two. In wet granulation method, fluidized bed dryers are used to dry the previously prepared wet granules. Powders are agglomerated in the drying chamber by spraying liquid binder over it. So while hot air dries the agglomerates to form dry granules. The next point application is coating of tablets. The fluidized bed dryer can be used for coating of granules also, and this technique is called as raster technique. Three designs are employed: top spray, bottom spray, and tangential spray. In fluidized condition, the powder is coated by coating solution sprayed from the nozzles. As the particles are coated, they become heavier. When the mass developed becomes heavier, then the drag force given by the fixed air velocity, the particles no longer floats. Advantages of fluidized bed dryer. Efficient heat and mass transfer facilitates high drying rates. Heating time of thermolevel material is minimized. Individual particles of the bed get dried in the fluidized state in the fluidized state. So most of the drying will be at constant rate, and falling rate period is very short. Temperature can be controlled uniformly. Free flowing product is obtained. Since the bed is not static, free movement of individual particle eliminates the risk of soluble materials migrating. Short time yields a high output from a small floor space. And similarly, disadvantages: turbulence of fluidized state may produce fine particles due to attrition. Fine particles lead to segregation, so they may collected by the back filters. Static charges may be produced due to vigorous movement of particles in the hot, dry air. This is all about drying, classification of dryers and fluidized bed dryer. Thank you.